Hello, pre-algebra. Welcome to lesson 4.3, Simplification of Linear Algebraic Expressions. The distributive law that we learned in the previous lesson is going to be used in this lesson to expand expressions by removing parentheses. So we'll get right into it. I'm just going to readjust this so everything that's important can be seen. We will move right along to try it 7, letter A, which gives us the problem of 5 times 2x plus 7y within parentheses. We are going to use the distributive property to distribute the positive 5 to the positive 2x and also to the positive 7y. To do that, we bring it over 5 times 2x plus 5 because it's positive times 7y. Simply doing that gives us 10x plus 35y. I can combine no longer because x's are different than y's. Therefore, 10x plus 35y is my answer to letter A. Throwing some negative numbers into the mix, I'm going to now in problem B have negative 3 times, in parentheses, negative 4a plus 8b. So I'm going to distribute that negative 3 to the negative 4a and the negative 3 to the positive 8b. And then at the tail end, I'm going to add 10b. So rewriting that, I first do the distributing. Negative 3 times negative 4, and then negative 3 again, times 8b because it's positive, and then I tack on that 10b, positive 10b. Now I actually do the multiplying, so negative times a negative is a positive, so positive 12a, negative times a positive is a negative, negative 24b, and then plus 10b. At this point, I can combine my b values because they are the same. So positive 12a stays the same. Negative 24b plus 10b is a negative 14b because when I add or subtract opposite negatives and positives, a word escapes me, but we actually subtract and assign the sign of the one that has the higher absolute value. So at this point, I could have dropped that plus sign, but I can leave it in there too. Triad number 8 actually has us distributing a letter, and this time to 3 values within the parentheses. So I'm going to distribute the positive c to the positive 4x, to the positive 6y, and the positive 9z. So it would be c times the 4x, positive c times 6y, positive c times 9z. At this point, when I start combining these things, this is something to pay attention to. We're still kind of working our way through this. We list the constants first, so the numbers first, and then all the variables, which are the letters, in ABC order. So this c times 4x becomes 4cx. Number first, letters alphabetical. Next one, 6 comes first, cy, and then 9cz. Well, cx is different from cy and is different from cz. They all have c's in them, but they also have different, the whole thing is cx. cy, cz, and the xyz makes them different, so that's as far as I can go, and that is my solution. Continuing with triad 8, letter B, I have 3 variables, expressions within a parenthesis times a negative 4d. I'm flipping this thing because I need to distribute that negative 4d to the positive 3m, to the negative 6n, and to the positive p. It just lines up better in my mind this way, so I just took this quantity and flipped it with this major quantity. You can do that. Associative property, multiplication. So negative 4d times the positive 3n, negative 4d times the negative 6n, and the negative 4d times the positive p. Again, now I have two constants here, so I must multiply. Negative times the positive is a negative, negative 12. My variables in alphabetical order, dm. Negative 4 times negative 6. Two negatives make a positive, positive 24. Again, alphabetical order with my variables, dn. Here it's just negative 4 dp. I cannot combine a dm or a dn or a dp. They're all different. Therefore, that is my final answer. Going on to try it 9. Here is a really interesting setup because you have 7y minus 3, and minus 3 needs to be distributed to this within the bracket. However, within the bracket, you have 4 minus 5 times 1 minus y. So you have to first do what's in the bracket, and there's a distribution within the bracket. So you got to do everything in the bracket before you can even think of distributing that negative 3 to anything, because you got to figure out what that anything is. So just copy down what you don't need. The first thing I have to distribute is the negative 5 to the positive 1 and the negative 5 to the negative y. So within this stays the same, 7y minus 3. Within the bracket, 4 stays the same, positive 4, but now I set it up. Negative 5 times 1, negative 5 times negative y. Then I figure out what it is, and I just keep this the same, 7y minus 3, and I end up with 4 minus 5, because negative times a positive is a negative. Two negatives make a positive, and that becomes 5y. Now within the bracket, I need to combine like terms. In this case, my constants are the only like terms. Therefore, keeping this the same, 7y minus 3, and I have negative 1 plus 5y. Now I can distribute the negative 3 to the negative 1 and to the positive 5y. At this point, I could have changed those brackets to parentheses to help me see that better. But if you go ahead and do a bracket, remember, if there's just two things within the bracket, it's sort of like parentheses. So going on, now I can distribute that negative 3 to the negative 1 and the positive 5y, which is what I did here. So I have 7y, negative 3 times negative 1, negative 3 times positive 5y. So I keep my 7y. I do this. Two negatives make a positive, so it's positive 3. A negative and a positive make a negative. I multiply my constants, negative 15y. Now I combine like terms. And remember, you always list the constant with the variables first, and you leave the plain constant dangling at the end. So I just rearrange it. 7y, negative 15y, positive 3. I combine my y's. Again, when I combine, I need to see which sign gets assigned to this combination, and since 15 would have the higher absolute value, it will be negative. I actually subtract. That is negative 8y plus 3. Another way you can write this, because sometimes people don't like starting the last expression with a negative. Sometimes they flip it and go 3 minus 8y. Either way works. This way makes more sense algebraically. Okay, now let's move on to try it 10. Try it 10 adds working with fractions. So letter A in try it 10 has 8p over 9 plus p over 3 minus 2p. Now remember, if it's just a whole number as a fraction, we would just simply add over 1 here, and that would make it correct. However, when we add and subtract fractions, we need common denominators, so we figure our lowest common multiple. In this case, it would be 9. Therefore, off to the side, the first value, 8p over 9, stays the same because it already has the denominator of 9. Positive p over 3, we're going to multiply by 3/3, which ends up being 3p over 9. And we take our negative 2p over 1, multiply that by 9/9, and that gives us a negative 18p over 9. So I just rewrite it here. 8p over 9 plus 3p over 9 minus 18p over 9. I just simply line these all up over 9. They are all variables with the same letter P. So I can just go from left to right and combine all of them because they are all the same. They are combinable. So I do the first two first. 8p plus 3p is 11p minus 18p. Again, using my order of operations and my rules of positive and negatives, I end up with a negative 7p over 9. I cannot make that any simpler. First of all, the constants can't be reduced. And second of all, even if they could, because of the p in the numerator, that is a value all on its own. There isn't any p in the denominator, so I couldn't even go on if I wanted to. So there you go, negative 7p over 9. Letter B gives us interesting thing, p plus 9 over 2. That's a little different. That's almost, well, it's not almost, it's as if there were parentheses around that because it becomes a single unit over 2 minus 3p, and I just threw the 1 under there because that's what it eventually becomes. So basically, I need to change my second fraction into something that has a denominator of 2. So I'm going to multiply 3p by 2, which is 6p. Okay, since I didn't have to do anything to this quantity, all I need to do now is line it all up. P plus 9 minus 6p over 2. I combine like terms. Now, unlike what's happening up here where everything had the same letter, only two of the quantities have the letter P. So I line them up together. P and negative 6p, and then the positive 9. I combine P and negative 6p gives me negative 5p plus 9 over 2. That's all the combining I can do, and that is my answer. Going on to try at 11. Things are going to get a little more interesting, a little more thinking. Now, notice in both of these fractions in my numerators, I have this quantity and this quantity. So I got to treat it as a single unit. Again, common denominators, my lowest common multiple is 6. So to do that, I multiply my first fraction by 3/3. That gives me 3 times this unit over 6. And my second one, I multiply by 2/2. That gives me 2 times that unit over 6. Before I can do anything and go on, I have to use the distributive property to distribute in the first fraction the 3, the positive 3 to the positive 2x and the positive 1. In the second fraction, I distribute the positive 2 to the positive x and the positive 4. So doing that, I rewrite it like this: 3 times 2x plus 3 times 1 plus 2 times x plus 2 times 4 all over 6. I actually do that. I have 6x plus 3 over 6 and plus 2x plus 8 over 6. Now I can line them all up, and at this point I combine like terms, so I get my x's together first, 6x plus 2x, and then my constants plus 3 plus 8 over 6. Do my combining, I have 8x plus 11 over 6. And that's as far as I can go. This was kind of nice. Everything was positive. particularly this part of it. In our next problem, this is going to be negative, and that requires an extra layer of thought. So let's get on with it. Letter B. Let's see. Okay, this is let's see if I can line this up better. There, I got it. So in letter B, I have x minus 1 over 7. Again, this is a unit. And here I have that asterisk because it's minus 6 minus 2x over 5. Again, this is tricky, and I'll explain that momentarily. And then plus 3x plus 1 over 2, another unit. First, think lowest common multiple. In this case, our lowest common multiple is high. It's 70. It is 70. So to do that, I have to multiply my first fraction by 10/10. So I'm going to distribute the 10 to the x minus 1. I'm going to come back to this one. The last one is pretty straightforward because it's a plus. I am going to distribute 35 to the 3x plus 1 in order to get 70. Now this one, go off to the side. Because in this case, okay, up here, this was a unit, this was a unit, and this is a unit. So I have this as my numerator for the second fraction, 6 minus 2x, minus 6 minus 2x. I need to get rid of that minus. The only way I can do that is to change this to a -1 and so I can flip my signs so that positive 6 becomes a -6 and this becomes a positive 2. And now I will have a plus situation here. I need that because I have to multiply the 5 by 14 to get 70. If I multiply that by a -14, I'd have a -70 in my denominator, and that would not work. I have to multiply by a positive number. I need a positive number there, and this is how I did it. That's the tricky part of this kind of problem. Now it's all set up properly, though. If this is one thing I would stop, rewind, re-listen, and really think about. If you don't understand, please call. All right, so I'm distributing the 10 first. I have 10x minus 10. Now the positive 14 to the negative and the positive. I have a -84 plus 28x. Positive 35 to both positive numbers is plus 105x plus 35. I combine all my x's and all my constants. When I combine all my x's, I end up with 143x because I just add the constant part of that variable x, and then I just simply work from left to right. I combine my two negatives and then my positive, which gives me a -59 over 70. This by far, this part right here is where a lot of confusion could set in. But just remember, you need the same denominator. That means multiplying by a positive number. You can't multiply by a -14 if you leave it like it is. So you got to make sure to change this -1 into a +1, which simply means that within the parentheses, the positive 6 becomes a -6 and the -2x becomes a positive 2x. Just flips the signs. Then everything is lined up properly. If you have a mistake in a problem like this, I'm thinking it would happen in that situation. So just keep that in mind. As always, rewatch this video if needed. Stop, pause as often as you need to. When you are confident that you understand all of the workings, your assignment for tomorrow is page 106. You are going to do number 1 through 2 letters C as in cat. This is a 3-day lesson because there's lots of thinking. And you really have to keep your positives and negatives, your distributive property, and combining like terms When we get to the fraction part, no fractions for tomorrow except one. Yeah, you just got to keep your wits about you. So we're going to take it slow. I need you to understand every problem and why it ended up to be that way. Okay, thank you very much. Do good math.